An introduction to artificial intelligence and automation. So the agenda today, we're going to look at automation in general and then how it applies to market research and jobs. Then we'll tackle artificial intelligence and how it applies to market research, and then a few thoughts about the near future. I always like to start with this example of what automation does. So if we go back to New York, 1905 was the first automation of bottle production. Before that, people blew the glass to make the bottles. Some of them were beautiful, but they were not very standardized. When the automation came in, the number of bottles that could be produced by an individual increased by 600%. The price per bottle fell to 8% of the previous price. So if they used to cost $1, they now cost 8 cents. Many skilled glass blowers lost their jobs because you didn't need nearly so many people to produce the same sort of bottles. What happened? The reduced costs and the increased consistency led to new uses for glass bottles. We saw medicines and foods and drinks being packed and stored in new ways into bottles, marketed. The consequence was a massive increase in the use of glass. Lots and lots of new jobs, tens of thousands of new jobs, but not for the artisans who used to blow the old glass. These were new jobs for semi-skilled laborers. Massive economic growth and massive health improvements because food was safer, medicine was safer, it was more predictable. That's the sort of thing that we can get with automation. What are the key benefits of automation? It can be cheaper, faster, scalable, and better. So cheaper because the costs fall. It requires fewer people to produce more stuff. The stuff can be produced economically. That almost always means that the prices to the consumer falls. And that can mean the market grows, but it doesn't have to. So there has to be something else to make sure that the market grows. Otherwise, what happens is things simply become cheaper. And if you think about making international phone calls, they used to cost a week's wages to phone from the UK to the USA for an average working person. And they're now pennies, cents. So they have become an awful lot cheaper. But actually, voice calls haven't increased over the last few years. They've started to decrease because of all the other alternatives. They can make things better, not everything. I would not want automated sushi. I would not want an automated hairdresser. But I absolutely do want to know that my iPhone has been built by a computer, not somebody with a soldering iron, hopefully getting it right. So some things become better, some don't. We need to be aware that when we look at automation, it doesn't always deliver all four. The best projects are cheaper, faster, scalable, and better. But this doesn't always happen. So everything needs looking at on its merit. There is no simple general rule. What about market research? We have a long history of using automation. We often beat ourselves up and we're wrong to do that. Go all the way back to the 1890 census. Herman Hollerith used the punch card to automate the process. He went on to create a company called the International Business Machines, better known today as IBM. Early automation. 1970s and the 1980s when I started. Optical scanning of surveys, computer-aided telephone interviewing, computer-aided personal interviewing. SPSS. When I was at university, we used to do all of those statistical calculations with logbooks, with tables, with slide rules. SPSS was a DIY automation process. Spreadsheets, desktop publishing, presentation and charting software, all of those were automation processes. 1990s and 2000s, online surveys, computer-aided qualitative data analysis systems, DIY surveys, online access panels, dashboards, masses and masses of automation coming through the process. And what we're seeing now in the current decade is shrink-wrapped research, the sort of things that you'll get from a Zappy store. We're seeing chatbots, text and sentiment analysis, image and video analysis, report automation, advanced analysis, for example, semiotics and conjoint. All of these are becoming increasingly automated, which means that the skill goes from highly skilled to semi-skilled. It means that the amount of product somebody can produce in a given amount of time goes up, and the prices tend to fall. There's an incredibly close link between automation and DIY. So we think about DIY when we talk about the ATM, the automated telling machines. But of course, SurveyMonkey, Vision Critical's online communities, Question Pro's communities and software, Conjointly's conjoint systems, InfoTools, graphics and reporting and so on, all of these DIY are built on automation. You can't have DIY in most cases without automation. What about jobs in the market research industry? Automation has already cost hundreds of thousands of jobs in market research. They were interviewers, they were data punchers, they were call center staff. Because we've switched over to online surveys so much, which is a form of DIY, because now people interview themselves once we put the survey up, all of those jobs have gone, hundreds of thousands of jobs. Automation will change existing projects and jobs. Now it's going to be people in the office, people like you and me, whose jobs may change, may disappear. We're going to see research become faster, cheaper, more standardized, and it will need fewer people hours per project. Many jobs will disappear and some new jobs will be created. So clerical jobs will decline, but storytelling, client success managers, their roles will grow. If the market for research grows, then there'll be a big growth in jobs. So if the fact that it's faster, cheaper, scalable means that there is much more research done, there will be more jobs, even in clerical jobs. But the time spent per project will be much shorter than before. So where the real benefit will be more Q&A, more interpretation, more sales, more storytelling is where we should see the growth most strongly. So let's move to artificial intelligence, very much the buzz topic of this year. It's an umbrella term, kind of cheesy diagram, I know. And on the left-hand side, all of these things, Bayesian networks, deep learning, machine intelligence, bots, inference engines, they're all types of artificial intelligence. There is no one thing that is artificial intelligence. On the right-hand side, here are all the sorts of things that are already using artificial intelligence. So obviously Alexa, Siri, autonomous self-driving cars, voice recognition, image analytics, chatbots, translation software, programmatic advertising, all of these are using it. And to some extent, anything that's clever is being called artificial intelligence. Pretty much most vendors of sophisticated systems will either say they're utilizing AI or they have utilized AI to develop the systems they're offering you. So let's not get hung up too much on definitions. Frankly, if it's really smart, let's just go with it being AI for the time being. There are some broad categories of artificial intelligence. The first three are all kind of overlapping. So algorithms, expert systems, and heuristics. Sometimes those get grouped together as just expert systems. Then we have machine learning supervised and machine learning unsupervised, which are massively different. They're as different from each other as expert systems are from machine learning. And then we have deep learning. And I'm just going to run very quickly through these. So algorithms, rules, expert systems. It's where the programmer puts the system into place. They know what the answers are going to be, they know what the questions are going to be, and they type up a system that enables it to work. So here's a really super AI example of playing noughts and crosses. If the opponent has 2 in a row, take the remaining square. That's the first rule. If that's not the case, if a move forks to create 2 sets of 2 in a row, play that move. Else, take the center square if it's free. If that's not possible, if an opponent has played in the corner, take the opposite corner. If that's not possible, take an empty corner if one exists, and if that's not possible, take an empty square at random. If you play against a computer with that really simple expert system, it will feel like you're playing against an intelligent opponent. This used to be, when I went at university, I did computer science in the 1970s, and AI was mostly around expert systems. But now, most AI you see and use and hear about is actually based on machine learning, much more common. Many market research applications, however, will have to use expert systems. If you want to know how to design a project or how to write reports, that is much more likely to use algorithms and expert systems than it is to use machine learning, because we don't have training sets of the sort we need. So what are training sets? What are learning systems? Well, supervised learning, this is the one that is happening all around us. Given a set of inputs and a set of outputs, the machine learns how to generate the outputs from the inputs. So, for example, maybe we have got 1 million open-ended comments. We get a human or a team of humans to code 1,000 of them, and we use those 1,000 as the training set. We give those to the computer and we say, can you work out from the open-ended comments how to generate these codes for this 1,000? And once the machine can do that, we can then say, okay, now please use that on the 1 million. This is how things like Google Translate works. This is how a lot of the analysis of images do. So, for example, when you get those terribly annoying captures where you're expected to recognize the pictures, you are part of the training set for the computer. Unsupervised learning, there isn't an output set. There is no training set. We only have input data. So the machine looks for patterns, structures in the data, and then typically the analyst has to redefine it and work with it. And frankly, cluster analysis is a super simple example of unsupervised learning. Deep learning is probably better called hierarchical learning because it uses multiple levels where the outputs from one level feed into the next one. So we could teach a computer to play chess. So that's a bit like using an expert system. We're going to give it the rules, and then we're going to give it some strategies. And then we're going to give it the ability to be a bit random as well. And then it's going to play itself over and over. So the results of the games it plays, the hundreds of thousands of games that it plays against itself, it uses as a learning set to keep improving. And that's why it's the hierarchical learning. You take the outputs and make them the new inputs. AI and market research. Chatbots and adaptive surveys are coming online all around us. Image, text, video analytics are coming online. You're going to hear some presentations about that this morning and this afternoon. Predictive analytics, attribution analytics, mining meaning from the data. All of these are taking place at the moment. The ones we're beginning to see, they're not really in strong commercial use yet, but they are coming through, things like Knowledge Hound, report writing and story finding. Project design and sample management are coming through, and you're going to hear something from P2 Sample this afternoon from JD Deach about sample management and AI usage. So in summary, most things that are clever are going to be called AI, and there's no point sort of battling against that and being pedantic and saying, well, no, really, that's just straightforward, heuristic. I don't think it meets this criteria. I would go with the flow. Most developments are going to happen outside market research and then be utilized. So don't write some new software. Go to Amazon Web Services, sign up, learn some Python, and you will find that you can utilize lots and lots of things that have already been written. Machine learning will focus on situations where a learning set exists. So there have to be thousands of examples that you can draw on where a known input created a known output. If we don't have thousands of known inputs creating known outputs, we can't use machine learning. AI will allow materials that have traditionally been analyzed with qual to be quantitatively analyzed. We're seeing that a lot. There's a recent presentation we had on automated semiotics, very much in that zone. expert systems are going to be core to things that don't produce those training systems. So project design, so analysis of research, so creation of reports are likely to be based around expert systems rather than machine learning. They will also use unsupervised machine learning to help find the patterns, but that will largely come down to the skilled user. And with that, I'd like to say thank you very much, and I look forward to questions.
Hi there, Ray. Thank you very much. That was a great presentation, and certainly so much takeaway learnings for me. So while we're waiting for some people to type out their questions, Ray, I've got a few of my own to get the ball rolling. Now, you mentioned learning Python as a skill that some researchers could undertake. Now, is there another skill that you think could become a core skill that researchers should keep their eye on now?
I think probably just experimenting with any of the smart artificial intelligence sort of based tools. So you might say text analytics. Can I get my hands on some text analytics software? And there is a lot of software out there that's free. Go and have a play and understand what it can do, what it doesn't do. There are systems out there that are looking at images again that you could look at in the free zone. Having a look at TED videos about this area of artificial intelligence, what it can do, what it can't do. Because I think what people need to determine is, where is their job going to be? Are they going to be creating AI? Probably not many people in the market research industry. Are they going to be adding to the machine some things the machine can't do? Definitely. And are they going to be managing projects where AI is one of the tools? Definitely.
And on that note, Ray, do you think that there are researchers who are working in particular areas at the moment that you think could be best placed to do that, to add to existing AI systems?
Really, anybody anywhere could be looking at it, and even if you're quite junior, then you're going to have this credibility of youth, and bringing that forward and say, right, I think we could do this another way. I think we could automate that. I think we could use this AI tool here. Similarly, if you're a more seasoned, veteran researcher, you can use your experience of the research industry to say, errors tend to happen here, so let's see if we could automate that. Or, do you know what? I always do the same things. Let's see if we can't put together a bit of an expert system that's going to tackle that and move forward. Then just experiments. The number of people who are trying chatbots in surveys and adaptive surveys is just growing exponentially. So if you're in the surveys business, you really want to be using that. If you're in the qual business, then you want to be looking at the tools that make you more effective, because you can look at more material, draw the strands together. You probably want to be looking more at the unsupervised machine learning, for example.
Mm. Yeah, so I agree there, and not just for the young people, as you say, Ray. Everyone can get involved, can't they? Exactly as you commented earlier. Ray, do you think that there is one thing in the future that could be automated, maybe a process or skill that could surprise some people, something we might not have thought of yet?
Well, I'm sure some people will have thought of it, but there was a science fiction story I read in probably the 1970s, where what we had was artificial intelligence set up to simulate customers. So in fact, if you had a new product, you showed the generalized artificial intelligence tool, here is the new product, and it would tell you how successful it would be and how to change it and how to use it. And I don't know if we could ever get there, but that really would be a very significant change to the world, where you didn't even think about testing it with people. You simply tested it against the computer to work out whether people would like it.
Yes, and indeed that happens in the games industry where playtesting can now be done with AI systems who also replicate player errors. And that throws up things that tells the designers, oh, well, that should be different. So, do you think that something like that could be used with survey design? So potentially run tests to see if actually AI systems detect any kind of user experience errors that could be improved in just general survey design.
Well, if we move back to the other part, automation, that already exists in most of the good platforms. They will run test interviews against the software. They will tell you whether particular loops work. They will tell you, some of them, about the readability. Some of them will tell you this is not going to be good on a mobile. So that process is undoubtedly going to increase, and undoubtedly it will be called AI. Whether or not it's clever or actually AI doesn't really matter. That process of checking surveys are right, which will then lead to some interesting arguments where the client or the very clever researcher are convinced their survey is right, and the machine is convinced their survey is wrong, and the machine will probably be right, but whether it will win the argument is another question.
Right. Okay, so thanks very much, Ray.
And thank you, Betty, so much for joining us as guest moderator.
Thank you. Take care.